This is section 5.3, theorems involving parallel lines, and objective 3. Okay, so we are going to do this rolled note paper experiment together as a warm-up for this video. So I want you to go get a ruler. So stop the video and go get a ruler. Okay, now here's my ruler. Okay, it says here, do math and you can do everything, no anything. Yeah, anyway. All right, so I want you to get a ruler and then draw a random line. I draw this one, but try to draw line that is not same angle, like, you know, do something like this or that or that. Draw a couple lines with different angles, maybe like that. Okay, and just pick one of them, and I want you to take a measurement. You probably want to use the measurement of the centimeter, so the tick marks are more smaller. So I'm measuring. So I want you to measure the distance between these, between the two lines. Okay, so I'm measuring here. It's about 2.8 centimeters. And over here is about 1.4 centimeters. And over here is about 1.4 centimeters. I don't know if you can see the tick marks, but that's where it is. Okay? Now, I want you to measure one of them. Okay? I'm gonna measure this one as well. This is 2.5 centimeters, and this one is 1.2 centimeters. This is about 1.2 centimeters. I don't know if you can see right around there. It's between like a 2 and 3, so it's like 1.25. See, yeah, it's 1.25. Okay, and I don't know what centimeters you got, but do you notice something? Yeah, this is 2:1:1 ratio, right? This is 2:1:1 ratio. And if you had a different lines and you measured it, even though the numbers are different, ratios are the same, right? So that's one of the things that you're learning today. It's the same here. And if I make something like this, so this is a triangle, right? If I measure here, this is 1.5, 1.4, and this is 1.4. So it's the same ratio, 1:1. And this one is about 1.5, and this is 1.5. So if you look at this way, this is a midpoint of this segment, right? And this is a midpoint of this segment. So I just want you to remember that if you connect the midpoints of the two different segments, these lines are parallel. So those are the relationships that you're going to learn in this section. Okay? All right, so let's start here. We are here. So after this, we're going to review and then have a quiz. Okay? All right, so objective 3 is apply theorems about parallel lines and the segment that joins the midpoint of two sides of a triangle. Okay. All right, so here's the theorem 5.8. If two lines are parallel, then all points on line are equidistant from the other line. given that these two lines are parallel and A and B are any points on L. It's random points on this line. And if AC is perpendicular to M and BD is perpendicular to M, this distance is this. You remember here, the equidistant, the distant means you have to be 90 degrees, right? From the point to a line for distance, you have to be 90 degrees. So that's what the given is, right? And why are they equidistant? Why AC equal BD? Here is the proof. Since AB and CD are contained in the parallel lines, these two segments are parallel, right? These lines starting with a parallel, so these two segments have to be parallel. Since AC and BD are coplanar and both perpendicular to M, they are parallel. So these are also parallel. Right? You remember, these two lines perpendicular to a same line are parallel. We learned that theorem. Thus, ABCD is a parallelogram. By definition, a parallelogram. Two sets of parallel lines, definition of parallelogram. Since opposite sides AC and BD are congruent, have to be congruent, that means it's the same distance. So that's the proof. That's a paragraph proof right here. Okay? All right. If three parallel lines cut off, here's a 5-9 different theorem. If three parallel lines cut off congruent segments on one transversal, then they cut off the congruent segments on every transversal. So it's saying that these three lines are parallel. So that's what this is. And if you draw a one transversal that goes over three lines, and AB is BC, meaning the transversal cuts it into two congruent segments, meaning that this is a congruent segment. Any other transversal that you cut on these lines are going to be congruent segment. These are all congruent. Congruent to each other. These don't have to be congruent. These don't have to be congruent. I'm saying these two are congruent, and these two are congruent, and these two are congruent. So that's what this theorem is. I want you to read this proof and see if it makes sense. Okay? It's drawing these auxiliary lines. Okay? You're drawing auxiliary lines parallel to these lines, and then let's see if it makes sense to you. All right, 5.10. A line that contains the midpoint of one side of a triangle and is parallel to the another side or passes through the midpoint of the third. So this is what we did on the first page, kind of similar. If two lines are parallel and then one goes through a midpoint, and then you have to go through the midpoint on the other side. Okay? And it's the midpoint of AC. Again, read the proofs and see if it makes sense. Okay? And this is kind of similar to this. This one is if it goes through a midpoint and the lines are parallel, then this have to be a midpoint. Okay, so N is a midpoint is the proof. This one is if these are two midpoints and you connect them, then these are parallel. That's this one. And these these are congruent. That's a given. So right, it's a midpoint. It's also that this length is 1/2 of this length. So that's this. Okay. So if segment that joins the midpoint of two sides of triangle, this line, the segment, is parallel to the third side, right? If it connects the midpoint of two sides, then it's parallel to the third side. And the half as long as the third side. This is 1/2 of this. Okay? Again, I want you to read the proof and see if it makes sense. Okay? There are two different proofs here. All right. Here is an example. P, Q, R, a midpoint of the sides of a triangle. So these are three midpoints. Okay, what kind of figure is D, P, Q, R? So this is a midpoint and this is a midpoint, right? So these have to be parallel, right? That was one of the theorem. If you connect the two midpoints of the two sides, it's parallel to the third side. And this is the same thing. So you connecting the two midpoints, so this has to be parallel to this. So these D, P, QR have to be a parallelogram because it's two sets of parallel lines. What is the perimeter of DPQR? So the perimeter of this have to be half as long. So this one is half of 8. So that's a 4, right? And since it's a parallelogram, this is also have to be a 4. And this one is half of this. So that's a 6, right? So this have to be a 6. Now, that's 10, but that's not, if there's another line here, that would be a 5. PR would be a 5. But since that's not being used, that's what we need. So this would be 20 units. Okay? All right, so let's do these. We're going to do evens in the video and then odds the homework, okay? So homework is to read proofs for the theorem and do these odds, okay? And then I think the rest we do in the class. All right, let's do 2. If xz is 10, then mn is 5 because it's half. That's 10, that's 5. 4. Zn is 8, then tm. All right, so these are midpoint, right? M and T are midpoints. So if this is 8, then this have to be 8. So that together that's 16. So this have to be 8. Okay, you do these. All right, 6. Suppose on x, y is 10 and yz is 14 and xz is 8. What are the lengths of the 3 sides of, okay, so there are 4 of these, so I'm going to do A and C. So these are homework, okay? Right, and then we're going to do this. Okay, so xy is 10, so these are midpoint, so that's 5 each. And yz is 14, so these are 7 each. And then xz is 8, so these are 4 each, right? So these are midpoints, so 10, 5, 14, 7. Okay, and the lengths of 3 sides of T and Z, okay, so that's a 4 and 7, and this length is half of this, so that's a 5, right? What are the lengths of the 3 sides? Okay, so we are not adding them, so it's just 4, 5, and 7. Okay, and then xmt. So this length right here is half of this, so that's 7. So that would be 4, 5, and 7. Okay, so you do these. Okay, and this one you do for homework. State a theorem suggested by exercise 6. So this is you, based on this result, you gotta spell out what the theorem this would prove. It's like this is not a theorem in the textbook, but you can, after you're doing this, you can prove that this theorem. Okay, all right. And 8, how many parallelograms are in the diagram? All right, so there is one here, and there is another one here, and there's another one here. So I think it's 3. Okay, we are done.